Hello viewers, welcome to Info Oasis, the oasis of information. This is our first video, and the first topic which we're going to discuss is black holes. So this is the first video of the space series. Likewise, we'll come up with a lot of other series like current affairs, science and technology, etc. And we'll try to provide you the best information possible. So let's start off with the topic black hole. So black hole, this is the first video of the space series as I mentioned, and we are going to be discussing 3 questions related to black hole. What is a black hole? How is it formed? And what exactly happens inside a black hole? What happens when an object or an entity is thrown inside a black hole? So let's get started without much ado. So the first question that we are going to answer is, what is a black hole? So friends, there are 2 ways to define a black hole, or you could say there are 2 definitions of a black hole. The first one is that a black hole is a region in the space-time continuum. So space-time continuum is an extent or a continuum which is formed when 3 dimensions of space and 1 dimension of time. We know that space is 3-dimensional and time is 4-dimensional. So when 3 dimensions of space and 1 dimension of the 4 dimensions of time, when 1 dimension of time and 3 dimensions of space, they sort of combine or mix and they form a sort of extent or a continuum which is known as space-time continuum. So in astrophysics, rather than seeing space as a unique or a separate entity, we always see space as an entity of the space-time continuum along with time. So in astrophysics, it's time and space are equally important. So what happens in a black hole is that, the gravitational force of attraction is so strong that not even light, the fastest known entity in the universe, can escape it. So I'll repeat, a black hole is a region in the space-time continuum where gravitational force is so strong that not even light, that is the fastest known entity, can escape it. Or a second way to define a black hole is that a black hole is a very, very, very huge amount of matter packed together within a very limited space. And the mass of this black hole should be around 3 to 4 solar masses. So technically speaking, if you put together 3 or 4 suns, or if you squeeze 3 or 4 suns together within a very limited space, you'll get a black hole. So black holes vary in size. The smallest known black hole has a solar mass of around 3.3 to 3.8, and the largest known black hole has a solar mass of 66 billion solar masses. Okay, so one solar mass is equal to the mass of 1 sun. So let's move on to the second question, that is, how exactly is a black hole formed? So a black hole is formed when a star dies. So first of all, let me explain to you how a star survives. Stars, they are enormous objects, enormous entities in space, enormous heavenly bodies. So what happens is that stars experience a gravitational force which tries to pull in the star within itself. That is, at the center of the star, there's a gravitational force which tries to pull all the nearby matter inside the star, and finally it makes the star collapse and blast. That is known as supernova explosion. So how does the star tackle this? To tackle this, star uses nuclear fusion reaction. It uses nuclear fusion reaction. So what exactly is nuclear fusion? Nuclear fusion is the combination of 2 smaller nuclei to form 1 large nucleus. It is completely the opposite. It's contrary to nuclear fission, where 1 large nucleus splits up into many smaller nuclei to release energy. So the energy released by nuclear fusion is much greater than the energy released by nuclear fission. So it is this energy released by nuclear fusion that enables the star to overcome the effect of gravity, and this makes the star expand because the energy released by nuclear fusion is so large. And the basic reaction that takes place is 2 hydrogen atoms combine to form 1 helium atom, releasing a lot of energy. So what happens is, after continuous nuclear fusion reactions, a point of time comes when iron is formed at the core of the star. So when iron is formed, further nuclear fusion cannot occur. So what happens is that nuclear fusion stops and the star starts to collapse within itself, and boom, a supernova explosion occurs. And this supernova explosion leaves a very small remnant core behind. For example, if the star was thousands of miles wide, the new core would have a width of only around 50 miles or 100 miles. It's very much little. So When this core has a solar mass of around 3 or 4 suns, then a black hole is formed. If it's less than that, a neutron star is formed, and we'll discuss about neutron star in the upcoming videos. So let's move on to the last question. What exactly happens inside a black hole? So for example, let's take a stellar black hole. A stellar black hole is it's a very commonly found black hole. There are about 10 million to 1 billion stellar black holes in the Milky Way alone. So stellar black holes have a solar mass of around 3 to 4 suns to 30 or 40 or 50 suns. Okay, so what happens is when you throw an object inside a stellar black hole, let's consider this as the stellar black hole, and this is the object which is, on its way inside the black hole. So even before it crosses the event horizon, okay, what is an event horizon? Event horizon is a point in the black hole where the gravitational force of attraction is so strong. I mean, it's the strongest. Event horizon is the point in the black hole where the gravitational force is the strongest. It's so strong that, whenever an object crosses it, it cannot return back. Not even God can save it or retrieve it back. So even before it crosses the event horizon, what happens is that this object, this object can be divided into two portions, portion 1 and portion 2. Portion 2 is away from the black hole and portion 2 is towards the black hole. So this portion will experience a greater pull towards the stellar black hole. So what happens is that this part gets expanded a little, and what happens is at a point of time, even before it crosses the event horizon, it rips apart. It is known as spaghettification. It's a scientific term. And let's move on to what happens when a supermassive black hole is taken. So if you don't want the object to be ripped apart, then you need a supermassive black hole which has a solar mass of billions and millions. So it has solar masses of millions and billions. Okay, so that is a supermassive black hole. So if you take a supermassive black hole, its gravitational force is large enough to accommodate the whole object, and it pulls both the ends of the object with almost the same force. So the body won't get ripped apart. So when you throw an object into a supermassive black hole and you go to a safer side and you try to look into it by using a telescope, you could see that the object goes deeper and deeper and gets dimmer and dimmer, and at one point of time you could see that the object stops, because at the center of the black hole we have a tiny, very infinitely dense, not tiny, a very infinitely dense singularity where laws of physics no longer apply, time freezes and space overtakes time. So what happens is that the object to you appears freezed. So actually what happens is that the object becomes one with the black hole, and if we personify the object as a human body, then the human is dead. So that's all for today. I hope you like the video. Please share it to your friends, hit the like button and subscribe it. I'll promise you that I'll come up with more cool content. So thank you all for watching. Subscribe. Thank you. Cheers.